Hello folks, so in this video I'm going to solve the LeetCode problem 1007 minimum domino rotations for equal row, and let's read up the question and then let's solve it in our local before we run it here. So I'm going to use Golang here. I'm actually starting to learn Rust. I want to use Rust also. I'll use it at some point. I'm not sure what is this off level 2. Anyways, looks like they even have some libraries. Okay, so I'm going to use Golang, and I think this is Go version 123, so that's good. It has support for data structures, Go data structures, and V2 version, V1 and V2 version, alpha version. So I have Go version 121. I think if I use GVM or just G, it looks like the version I use is coming from Brew. Anyways, I'm just going to use 121 for now. Maybe in the future I'll just use Google Lang Version Manager and manage my versions. So let's get started. So in a row of dominoes, I was actually checking out what is a domino, and I realized that it's just a tile game. I've seen it, the tiles, a lot of tiles kept and them falling down one by one. There's even a question based on that, I think, separate question. But this one, apparently, you can play a game with it and not just push it around and make it fall. So apparently, each tile has two boxes, and the boxes have some numbers, usually from 1 to 6. But I think in this case, the number, oh yeah, it is from 1 to 6, right? Sometimes it can be more also, I think, like 9 and all. I noticed there are some dominoes which has 9 and all within one box. So in a row of dominoes, so tops and bottoms represent the top and bottom halves of the ith. So tops of I and bottoms of I. So ith domino. So let's say this is the zeroth domino. Tops of zero is the zeroth domino's top, and the bottom is this. Behind this, there's nothing usually. So this is one tile, one domino. And we may rotate the ith domino so that tops of I and bottoms of I swap values. So return the minimum number of rotations so that all the values in tops are the same, or all the values in the bottoms are the same. Basically, for example, if this is the case, you have two here and two here also. Twos. Now you can actually rotate this and rotate this, and you'll have twos all over. So you can see over here. Right, so that's like two rotations, right? The first figure represents the dominance as given by the tops and bottoms before we go in it. If you rotate the second and the fourth, we can make every value in the top row as equal to 2 as indicated by the second. So if you cannot do any rotations, if it cannot be done, then minus 1 back. So I was thinking about what is the algorithm that I can apply for this. We'll come to that. Before that, you can actually see the constraints that the length of the tops is basically minimum is 2 and the maximum is I think this is 10K, so 20K, and the length of tops and bottoms is the same because it's the top of one of the uh, dominoes. So the bottoms, if there are that many tops, there should be that many bottoms also, or else you will just have half a domino. So and then the each value in the top or in the bottom is actually between 1 and 6. Right, so that's a good thing. Some optimizations that we can do is we know that it's only this 1 to 6. We can use, for example, bit representation and whatnot if needed, and have very specific set of values because specification and mainly making a problem specific uh, makes it easier to solve with performance. When it's more generic, it's harder to solve it with performance. When it's more specific, you can use the specific details to make it performant. So these are the details. I'm going to see if I can actually just copy this question and put it in my VS Code. So I'm just going to create a problem saying make directory. I'll just say 1007 will be minimum domino rotations per equal to okay 1007 minimum domino rotations for equal row and go to this, open up, and okay. So now I can just paste this and that's the question. So I'll just put it as a readme. So for now I'll do that and example 2 and the constraints. Oh, this is okay. So I'm just going to close this up. I'll copy this and close this up. So now I'm going to actually write the code here. I'll just say pkg.go, right, and have this. And I'll have a package test.go for testing, right? I'll call it as package for now. Call it as pkg for now. Oops, not pkg. And I'll just call it as domino, domino. I'll call this as the test and that as the thing. And I'll put these two inside it, right? And I'll just say domino, um, domino, and have these two inside this. That should name this as domino. No, that's the test. This one is domino. Okay, so this is going to be package domino. This is going to be package domino, and then I'm going to have a test over here for testing this minimum domino operations. I'll just, oh, it's in the same package, so I think I'm doing this. I'll just call it this, and okay. And in extensions, I'm going to go ahead and use the Go extension, enable for this workspace, and we're good to go. So now it says Go, please is not able to find modules in your workspace. Oh yeah. So I'll just create modules, Go mod init, and how have I done it in previous ones? Let me just check. So add two numbers, go.mod was add two numbers, right? So I'll just say copy this and copy that. This is go mod init and this, right? Do that. Great. So now I think it should be fine. And here I'll just say return 0 for now. Actually -1. So it says no usage. Okay, so we'll just use it up in one case. Let's have test cases, right? Test cases, test cases, and I'll define a test case. Um, and test cases is I'm going to define a type. Sorry, this is a type. It's a structure. This is array of test case. Okay, and let's say input, output. Yeah. So let's say input. Let's say test case input. Output is test case is this test case output. Test case input is basically a struct with tops array of integer and bottoms an array of integer. Right? Test case output is basically just an integer. Um, with an int. Can you just say this? Interesting. Can you say this? Okay. I wonder how it's different. Okay. I put this, does it still go? Yeah. I put this, no, that's not. Let me just say this for now, I think. So if I click this, it goes here, and this is basically just this. If I put the type is equal to this also, I think it just takes that. And I can go ahead and say test case. It's an array of test case, okay. Oh, test cases. Test case. Okay, and so this one, I will just say just a moment. So input, this case input, and I think that's it. Or more like expected output, right? This call is expected output, and yep, we have the input and our output. That's all. I think we're good to go. This do this, and let's say one. Yeah, or we can just say one. I think it will still work. I think. So yeah, and even if you say equal to also it will work. I'm just not going. I'm going to remove the equals. And for example, we have one example over here, right? Um, we can take this example and put it up. Um, Tops, yeah, and bottoms. And the minimum rotation is 2. I think we can have simpler test cases first, but I mean, these are a bit tricky test cases. This is -1. So just put this in here. Let's put up -1. Let's put up a simpler test case. In some cases, you will just need zero rotations. Right? For example, if it's just the same value, 2, 2, 2, right? Um, I mean, if it's just one thing, then you don't need any rotations. right? What you have something like 2, 2 and 1, 1, 0 rotations. You have 1, 5, 0 rotations. Even the bottom should work, right? Same thing if it's in the bottom. It says 2, 5, and this is 5, 5, it should work. Um, and bottoms all equal, tops all equal, both equal, 0 rotations, 0 rotations, right? And now we go with one more thing where we say one rotation and we should be good to go, like something like that. So we'll say 5 and here we'll say 2. One rotation, right? For two rotations we have here. So let's have two rotations in a different way, right? This is one rotation. Let's have one more rotation. Two, right? So minimum rotations. We can just rotate this actually once. Why do we have to rotate this two times? This is just one, right? Minimum rotations. So ideally, the one which has lesser, it should just be rotated. This is count once, we'll just rotate this. And if it's equal, yeah, then we have to rotate it. This is also one only. And there's going to be two now when we have two on the top. If I have two on the bottom, then it will just be one. If I have two on the top, and then say five, right? So that is that. And we need some more minus one phases. We have those. So, okay, so let's look at how we'll solve this, and then in another video I'll just solve this up. So I think the idea is going to be something like uh, parse through the tops first. I mean, I'm not looking at multi-threaded here for now. So parse through the tops first, and if all the values are equal, then stop and just say that you don't need any rotations, 0. And while parsing through, if even one value is different, you start while noticing if it's the same value. Apart from that, also start keeping track of the values because it doesn't have to be equal. So keep track of the occurrences, number of occurrences of each of the values. If it is 2, then store the occurrence that there are two twos, you know, and every time you store the occurrence, check if the total number of occurrences is the same as the length of the hops. Then in that case, it's just straightforward that you already have the answer. And apart from that, go in the bottoms. And when you go to the bottoms, when you actually keep track of the occurrences, next thing to do is actually, um, go ahead and look at when you say, for example, here it's 5, 2. So here you have four twos, right? Four twos. When you start counting the twos here, what you do is you start checking how many twos are there. So four twos, so here one, two. Totally, how much is it? It's five twos, but you still have six twos over here, so you don't go for that for now. What you do is next you do is you see how many twos. Next, you see that there is one more two here, right? you basically say, okay, there are six twos now. I can just swap this, right? This two you can't swap because it doesn't make sense. But yeah, once you get the six twos, you will be like, okay, there are four twos on the top, two twos below, and here actually you can stop, right? Um, but what happens if you actually have one two here, right? So you should ensure that the top of this two is actually not a two, because let's say one of the twos is here, four twos, six twos, it becomes a problem, right? So that is a tricky thing to note. But other than that, I think we're good to go. So that is the logic that I'll be applying. I will solve this in another video. I'll see you next one. Bye bye.